but kind of getting into some of the premise of what we're going to eventually and how this is all going to work. Here it says, determine if the following are factors of the function. Now, do you have to do the division for that to happen? No. By the factor theorem and the remainder theorem, those two kind of working together, x minus 3 would be a factor if 3 is a root. So I'm looking to see, is the root 3? And basically a root would be if I plug 3 into f of x, and if I get 0, it's a root, which would make x minus 3 a factor. And that's what happens here. I plug 3 in, it becomes 0, therefore x equals 3 is a root, which makes x minus 3 a factor. And again, the word root can sometimes be referred to by the actual textbook as a 0. A lot of calculators refer to it as a 0. But I've also seen questions on WebWork that'll call it a root. Please make sure you know they're the same thing. Okay. X plus 2. Well, x plus 2 being a factor means that negative 2 would be a root. So is it? I plug negative 2 in, I get negative 30. Which means if I would go through the long, arduous process of dividing x cubed minus 6x squared plus 5x plus 12 by x plus 2, I would find out that it would be some expression and then it has a remainder of negative 30. Whereas I can figure out what the remainder is without having to actually do the division. So here, x equals negative 2 is not a root, therefore x plus 2 is not a factor. And lastly, for x minus 4, that means if I'm looking to see if that is a factor, that means that 4 would be the root. I plug 4 in to f of x, I do get 0 as a result, which tells me 4 is a root, which means x minus 4 is a factor.